Hi ladies and gentlemen, let me welcome you to the second session on EST 102 C programming. In the first session I told you about the use of programming and why we do programming. Programming is done for the automation of tasks, automation of boring and repetitive tasks. Then I showed you a picture depicting job opportunities in job opportunities with programming tools and computational tools. So especially for electronic students. So in this video, today's video, we see the basic input-output operations in C. So the learning outcomes of today's session are first you will appreciate the learning materials for this course, then you will learn about Linux operating system, then you will observe the demo of basic Linux commands. Then you will learn to display messages on the screen with printf and stdio header. Stdio is a header file that is extensively used in C programming. We will know more about that. And printf is a function provided by the stdio header file that is used for formatted printing on the screen. And then you will learn to get data from the keyboard with the scanf and stdio. Scanf is another function embedded in stdio. Then you will learn about some basic idea about variables in C. So these are the learning materials. The first book is a very interesting one, that is C Programming, an absolute beginner's guide. You can read this. Then Programming with C, that's also a great book on that. Then when you work with the Linux, you have to know some basic Linux commands. So Linux shell programming is another very useful and powerful tool when you work with when you work on computers. So the Linux command line, that also you can read. Much of the thing we do in the lab in C programming is on Linux machine. So Linux is an ASCII text-based open source single root operating system. What this means is much of the thing in Linux operating system that is based on ASCII text. For example, in Windows you do everything with the help of some dynamically linked libraries or DLL files, while in Linux everything is ASCII text based. It is open source in the sense that the code is open to you. That is, you are allowed to modify the code without any legal issue. And again, much of the tools are free also, free of cost, given free of cost also. That is the meaning of open source. And single root operating system means the file system is a single root one, unlike in Windows. So for example, in Windows it is basically Windows is a single user operating system where you have many roots, like you have a C drive, sometimes you have a D drive. Under the C drive you may have my documents, my pictures, etc. So it is for a single user, so it is not to be shared with many users at the same time. So it is a multi-root operating system. So, but the problem is there are some security issues, like if I am, say, using a Windows machine and I am putting a question paper in the C drive or in the D drive and I leave it there, and if the student comes and he can access the D drive and see the question paper. So there is very little security in a Windows system, but that is not the case with a Linux operating system. Linux is a multi-user system. So in which many users log onto the same machine at the same time. So there will be different users using the same system at the same time. So there will be a root file system. So the root user is a super user, or the administrative user who has a lot of powers, and but he or she is an unstable user, because while you are logged in as the root user, many people can remotely use your system and do bad things with the system. So generally we have a root user for administrative purposes and non-root users for ordinary computational purposes. So it's a single root operating system where the root slash, that is your total file system, and under that you may have like a boot directory, like you may have a home directory. Under the home there may be home for many users that way. So it's a single root operating system. It has greater security and reliability, which makes an ideal choice for server class systems. Most of the servers around the world are working on Linux or some Unix. Linux is a Unix. So here the Linux is also written in C, as most operating systems are written in C, and the GCC compiler can compile the C source code in Linux. So the default compiler in the Linux is a GCC compiler. So I will tell you the use of all that in this video. And Linux shell is a very powerful tool in during the development of Linux and computers. Initially, there were no graphical user interface, so people were working from the terminal, or rather called a shell. And this shell in Linux is a very powerful utility. That is, you can do many things like surfing the net, sending the email, etc. Everything is possible from the shell. But when GUIs came, you may have a GUI in your Linux machine. So this machine, this has a what do you call a GNOME GUI. Sometimes you have a CAD desktop environment in some systems. You may have lightweight GUIs like the XFC, etc. So when these GUIs came, still people needed that shell. So they made an emulation of the shell in the GUI that is called a terminal. So one can email surf the net, etc. from a terminal, but you may not have the graphics in that. But and some important shell commands are like, if I say here ls is it lists the contents of a directory. So a directory is like a folder in your Windows system. And cd is to change from one directory to the other, and cp is to copy a file from the current location to another location. The pwd is a person working directory, so where I am, I want to know. Then ssh is for secure shell for remote login. Suppose Linux, I told you, is for multi-user system, so many users may be connected to the same machine. So suppose I want to connect to my system in the lab or a server in the lab, I can do with the ssh, provided I have SSH facility enabled on both sides. Usually I use a Open SSH client and Open SSH server installed on both machines. So you can connect to other machine with the SSH. So I will give you some basic idea about this. So I will open a terminal here. So this is a Linux machine. This is an Ubuntu 18.04. It's a little older version, and here you can have this. If I look here, when I invoke the terminal, I am currently at the root directory. I will show this by passing pwd. Here you can see that the person working directory is /home/Harry, meaning that this is my root file system, the old file system. Under that there is a directory called home. So this home may be the home for many users. So under that, this is the home of the user Harry. So if I type here ls, you can see so many files here. These are the files in my home directory, files and folders in my old directory. So if I want to change to, say, another directory, say here I want to change to the hard disk where I keep the /media/Harry/HDD, suppose. Now I have moved into CD media/Harry/HDD. So where are my courses kept? I kept all my courses here, CD courses. I have here. So in this I will go to the at College of Engineering Chenganur. Where am I? So I go to the year 2023, CD year 2023. So I am here. So I take many courses here. The person course is a EST 102. So I go there, EST 102. So this is a directory where I keep my the details corresponding, the documents corresponding to this course EST 102 C programming. So here I have the books, the course diary, the manual for your lab, problem sets, videos, talks, etc. Okay. So this is how I move from one directory to other. Then if you say pwd here, you can see that I have a different directory now. So likewise, I can use a cal command to know the calendar. You can see that if you use a command cal, then you can see the calendar with the today's date highlighted. Okay, so you can play around with the many Linux commands. And when it comes to the history of C programming, C was developed in the 1970s by Dennis Ritchie at Bell Laboratories. In the mid 1980s, the popularity of C had become widespread. Numerous C compilers and interpreters had been written for computers of all sizes, and many commercial application programs had been developed. Then the American National Standards Institute, or ANSI committee, has developed a standard definition of the C language. Now almost all C compilers follow the ANSI standards. Now what is the structure of a C program? C programs are a collection of functions. Okay, so in C, you have to be very thorough with functions, how to write functions in C. In modern languages like Python, Java, etc., you have an additional thing called classes, where in languages where the object-oriented features are supported. Object-oriented programming is a very useful thing. So Python is a fully object-oriented thing. Everything about Python programming is everything in Python is an object. So in object-oriented programming, you have a higher thing called a class. But C does not support any classes. C supports only up to functions. So writing C functions is very important. So C programs are collections of functions, one of which is called a main. That is a main function. So there's a main function there. That's a principal function. The program will always begin by executing the main function. So whenever you execute a C function, C code, what actually you are executing is what you execute is a main program, and that main program may be calling other functions. Main function may be calling other functions. So suppose when you look into the code, the main function may be calling some 4 or 5 functions. So each of these functions will be calling other 4 or 5 functions. Those 4 or 5 functions may be calling many other 10 or 15 other functions. So you have to go in when you do the programming, you have to go in a very modular style. So there may be other functions in the code, each of which contains a function name, argument, and some statements. So this is the structure of a function. A function essentially contains the name of the function, then the arguments into the function, and some statements. What is to be done in that function? What commands are to be executed? What tasks to be done? So they are accomplished by some statements. So a function contains a function name, the arguments to the function, and some set of statements. Now, when you come to the very basic need, you have to communicate with peripherals such as a keyboard or the terminal. So how it is done, we will see that. Now, before going into that, you have to know some basic idea about variables. So I'm putting it in a very terse manner here. A variable is a name of the memory location where C holds a value. So suppose you want to add two numbers, say A and B, and you have to produce a result C. Then this A, B, C are variables. Okay, A, B, C are variables. So what are these variables? They are the name of the memory locations where you hold the values A, B, C. Though these A, B, C's can be, or these values can be integer, can be float, it can be a character, or it can be a double. Okay, so if I say A is an integer, then the system reserves enough space for holding that integer. If it is a float, it reserves the space for holding a floating point number. So there's by default there is no string variable in C, but instead you use arrays. Arrays are used. The character arrays are used as strings. The value of the variable can change, like the value of A can change. Say, suppose I define it as an integer, and the value can change, say, from 2 to 4 or 4 to 8 or something like that, but the type cannot change. It is always the same. Once you make a declaration about the variable, when you start the program, you have to make a declaration about the variables, and once you declare the variables, the type cannot change. Throughout the execution, if A is put as a float, it is always a float. If it is declared as an integer, it will remain as an integer. So a variable declared as float can only floats are not integer or character. Now let us look at a very minimal C code. Okay. So this is a very minimal C code that print out hello to the real world. So every programmer starts his program with a hello world program, and what it does is, if you look into the first line, what that says is hash include stdio.h. What does this mean? And in that, under that, there is a main function. As you can see, there is no main function, and in this there are some statements. So you can see that the name of the function here is main, and there are no arguments. Arguments are held in this usually held in this brackets, but they are vacant now, that there are no arguments actually. Then there is a set of statements here, only one set of statement, print of hello, and this hello is a string, that is why they are put in quotes, and this statement is ended by a semicolon, and these statements are put within braces. This is the structure of the C program. Now, whatever statements are there, it is wise you give it as an indented block. So it is always wise, and it's a good practice to put your code in indented blocks. Like whatever is coming under the function main, you put as an indented block. It is not mandatory, but it is good. Like if I put the whole thing like hash include stdio.h main, the whole program in one line, still then it will be executed. But the program becomes very readable if you use proper indentation and all. And mind that you have to give as many comments as possible explaining the code, so that another person can understand it very quickly, and you can communicate to your peers or your group members very quickly. So let us once again look at this code. What is the first line doing? Line number 1. It is hash include stdio.h. What it does is it includes a header file stdio.h. What this says is it is a standard input output header file. Okay, it's a standard input output header file. Header file is nothing but a C code, only it is saved as a header file. But where is this C code, or where is this stdio.h located? What is the significance of this greater than less than sign? Because this shows that this greater than or less than sign, this shows that this stdio.h is a system header file. It is a system header file, and it is not a user generated one. It is a system header file. And where is this stdio.h? In my Linux machine, it is available in /user/include. We will see the presence of this thing here. I will come here. I will get out of this by now. I have come back to, when I simply type cd, it comes back to my home directory. Now if I go to cd/user/include and you type ls here, you can see this stdio.h file here. Here there is the stdio.h file. Okay, it is from here that I include this file. Okay, here you can see that this is a stdio.h file. You can open it and view this file. Like you can say this Linux is full of editors, because I told you Linux is a text-based, ASCII text-based operating system, and Linux is swarmed with many types of editors like Nano, VI, Medit, Gedit. So many editors are there. So I use Nano here, but I strongly recommend that you familiarize a VI editor. Okay, with the VI editor you can do a lot more editing functions, but here I use a basic editor that is called a Nano, and I write stdio.h. It says that it is not writable. Okay, I don't want to write anything into that. You can see this function here. You can see this C code here. In that there is a function called printf, scanf, etc. Printf, scanf, etc. are available in this code. It is from here that I include the stdio.h in my code, and stdio.h provides me functions like printf, scanf, etc. So I get out of this by pressing Ctrl Z. Now let us go back to my presentation and see what is happening here. Now, when I say hash include stdio.h, this stdio.h system header file, that is included from /user/include here. So then I start a program main. Every C code should have a main program. So main is followed by arguments. There are no arguments here. There is no argument to be passed on to this main function. Then your set of statements, they come within braces, and this statement I put as an indented block for readability. So printf printf hello within quotes and ended by a semicolon. So what this does is it prints the statement hello in my terminal. Now let us look into this. Let us look into this code. This is my code. Okay, I will write like my previous code, whatever I have written there. I press Ctrl S. Okay, I open a terminal here. I close my earlier terminal, I don't want it here. Here I can right click, I can open a terminal here. So this is my code, hash include stdio.h main printf hello. Now let us run this code. So how do I run this code? I run with, I compile it with the GCC compiler. So I say GCC new.c, okay. So the new.c is my source code, C source code. So it is wise I specify an output file. So I specify say a.out. Conventionally programmers will use executable as a.out, or you can. Now it has shown a warning. It doesn't like my function starting as main, so it is not returning anything. So I should have said void main. I will come back to that. So here I have come back to this. So here now an executable a.out is written in this directory. Here you can see that there is an a.out here. So I can run this a.out, this executable, by pressing \a.out. Now you can see that hello has been printed here. Hello has been printed in the terminal. The word hello has been printed here. Hello is printed here. Now you can go back to this code, and I can change that warning. I can get rid of that warning by saying void, okay, because this function is not returning, and so the whatever it is returning is a void thing, and print. And now I can put a \n here to this \n is a new line character. It will come to the, after execution of this, it will come to a new line. So I'll go back here and run this again. GCC what is it, new.c, then I have -o a.out. Okay, then I press a.out. Here you can see that the warning has this return type defaults to int. This warning has warning is now gone because I have specified it as a void. Now again you can see that here it was printing like this. Now it is printing this terminal starts in a new character. This is the effect of the \n character there. So this is how I print hello to my screen. Or if I change this statement to something else, like I can say print hello world. If I execute this, here you can see that now it prints hello world. Now this is how I run the code. Like I use some editor to type my source code into that. Then I open a terminal here, or I navigate to that point or navigate to that folder. Then I type gcc filename.c -o, some name of some executable, some a.out name .out. It is wise you don't give the same name for your executable and your source code, because if some error comes, your output may overwrite your C file. So as far as possible, give us different names. I always give a.out. So I have seen this demonstration. Now you familiarize the use of the printf function. Now let us see how the scanf function works. Okay, the scan function, how the scan function works. Now I want to read something from my keyboard and store it in memory. Okay, so how do I do that? This small program explains that. Like this is my self same line, that is hash include stdio.h. What is it doing? It is including stdio.system header file. Why do I say system header file? Because it is provided by the system. This greater than less than sign shows that it's a system header file. Where is this located? It is located in my Linux system. It is located in /user/include. There is a header file which is a C file called stdio, standard input output operations. So that takes in here. This gives me a function scanf and printf. So I start a main program here, main. Okay, void is actually I should have written void main. We will come to that when we do the demo. We will see that. Then I start my code with within these braces as an indented block. This indentation is for easy reading of the code. So here I have to use some variables because I have to read the keyboard entry into some variables and store in some memory location. So for that I have to use, whenever I have to put into what is a variable, it is the name of the memory location. So I have to declare those memory locations. So here I use 3 locations. What this code does is it reads 2 numbers from the terminal. From the keyboard, and sums them up and saves as a new variables C. So here the floating values here A, B, C are declared as floating variables. So float A, B, C, A, comma, B, comma, C, followed by a semicolon. Then I printf. This is for giving a prompt to the programmer, like printf, enter the first number. So this prompts the programmer to enter a number. So when he key in the number, that is scanned with the scanf function. Okay, how do I do that? This scanf function is provided by the stdio.h header. So scanf ampersand a means this actually a kind, this ampersand sign shows a kind of address, or when we discuss pointers you will understand it much better. Just for the time being, understand that it's a address of a memory location where I store this value a. Now this %f means that it's a floating value. It is to be reserved as a floating value. So %f comma ampersand a followed by semicolon. All statements are followed by entered by semicolons. So once A is read, I have to read the number B. So for that another prompt is given, printf, enter the second number, \n for the next line, for new line character. Then scanf %f ampersand B means the B is also read. Now I have to add these 2 numbers A and B. I can use A plus B, C is equal to A plus B. Such things are supported in C. This arithmetical computation, C equal to A plus B. Then printf, the sum is %f C. What this says is the sum is %f means here the value, numerical value of C will appear in the statement. Okay. The value of C will appear here, the sum of C. So if A and B are 10 and 2, so the result will be, so sum is 12. Okay. So we will demonstrate this code. We will go back to the directory where I store this code. There may be IO1. Yeah, here is the thing. So this is my code, hash include stdio.h. It includes a header file from user/include. Then void main. I have put void main to remove avoid any warning. So then within braces, first I have a definition of the ABC, or a declaration of ABC rather, not a definition. It's a declaration of ABC as floating variable. Then I have a printf function. This is a prompt. A is read. Then another prompt, B is read, and C is computed as A plus B. Then the result is displayed. This I will run here. This code is io2.c. I will come here. -o a.out. Now I am overwriting the a.out in that directory. Here it is compiled without any error, so I will type a.out. So it asks for the first number, so I write say 12.35456, something like that. Then I say 45.378. Okay, that's the second number. Now it displays the sum. The sum is 57.843601. Okay, I haven't specified any position for this. That is why it gives in the arbitrary position. The sum is 57.843601. So this is how I use the printf and the scanf functions. So this is how I do the basic input-output operations. Now I come to the end of this video. Here the summary of understanding. Then first you appreciated the learning materials. You have to do the code from those. You have to read that book, and you learn programming not by reading but by doing. So whatever is in the book you do on your system and understand that. You do as many codes as possible. Then you learn some basic concepts about the Linux operating system. Then you observe the demo of basic Linux commands. Okay, like cd, change directory, calendar, the pwd, the cp, the what do you call, the ssh, etc. It is wise you learn the Linux shell programming also. Then you learn to display messages on the screen with the printf and stdio header. You understood where the stdio header is located in a Linux system, and how that is included in your code, and this stdio is providing me two functions, printf and scanf. So this is how it is. You see how this is happening. Then you learn to get data from terminal with the that is from the keyboard actually. How to get the data from the keyboard with the scanf and stdio header. Then you learn the variables in C, and that is the end of this presentation. I thank you all.